Have you ever felt like you were being watched? That sensation is more than just paranoia. At the quantum level, the universe really does seem to notice when we look. Imagine a world where the act of observation changes reality itself. In the quantum realm, particles can be in multiple places at once, behaving as both waves and particles. This isn't science fiction, it's the foundation of modern physics. The rules of our everyday world break down at the smallest scales. Here, observation isn't passive, it shapes what is real. Our journey into this strangeness begins with a simple experiment that changed everything. It's called the double slit experiment, and it reveals a universe far weirder than we ever imagined. Prepare to have your view of reality shaken. The universe is not what it seems. Let's see how a simple question about light led to a revolution in thought. In 1801, Thomas Young set out to answer a deceptively simple question. What is light? Was it a stream of particles, as Newton believed, or a wave? Young thought that if light was a wave, it should show interference, like ripples from two pebbles in a pond. He set up and experiment sunlight through a single slit, then through two parallel slits, and finally onto a screen. The idea was to see if light would act like particles, making two bands, or like waves, creating an interference pattern. Young's setup was simple, but its implications would echo through centuries. He was about to ask light a question that would change physics forever. The answer would be astonishing. Imagine throwing sand at a wall with two doorways. You'd expect two piles behind the doors, classic particle behavior. If light were made of particles, Young's experiment should show two bright bands. But what if light is a wave? Picture water waves passing through two openings. They spread, overlap, and create a pattern of alternating highs and lows, an interference pattern. On the screen, this would look like a series of bright and dark stripes, not just two bands. The double-slit experiment would reveal which theory was right. Two bands would prove the particle theory, an interference pattern would prove the wave theory. The stage was set for a decisive answer. What would light reveal? Young's experiment produced not two bands, but a beautiful pattern of bright and dark stripes. This was the unmistakable signature of interference, proof that light is a wave. The bright bands showed where waves reinforced each other, the dark bands where they cancelled out. Light, it seemed, could pass through both slits at once, just like a water wave. The wave theory of light triumphed, settling a centuries-old debate. For nearly a century, physics embraced this elegant answer. But the story wasn't over. Young's experiment had opened a door to even deeper mysteries. The true nature of light and reality was about to get stranger. In the 20th century, new discoveries showed light also acts like particles, photons. Physicists revisited the double-slit experiment, this time firing single electrons at the slits. Each electron hit the screen as a single dot, like a particle. But as more electrons were fired, an interference pattern emerged, just as if each electron had gone through both slits and interfered with itself. This was shocking. How could a single particle create a wave pattern? The electron seemed to exist as a wave of possibilities, exploring all paths at once. Only when it hit the screen did it become a single, definite point. The quantum world was not just weird, it was fundamentally unpredictable. Reality, it seemed, was a matter of probabilities. The act of observation would soon prove even more important. What if we try to catch the electron in the act, watching which slit it goes through? Physicists placed detectors at the slits to observe the electrons' paths. When observed, the electrons behaved like particles, forming two bands, no interference pattern. But when the detectors were off, the interference pattern returned. The act of measurement changed the outcome. It was as if the electron knew it was being watched and chose a single path. Observation wasn't just passive, it shaped reality itself. Before measurement, the electron existed in a cloud of possibilities. Our observation forced it to pick one. This paradox lies at the heart of quantum mechanics. The double-slit experiment forces us to accept a universe that is fundamentally strange and probabilistic. Particles exist in a realm of possibilities until observed. This wave-particle duality is a core principle of the cosmos, not just a quirk of light. Reality depends on the questions we ask and how we look. The experiment has inspired endless debate and multiple interpretations, from Copenhagen to many worlds. It doesn't give us all the answers, but it lays bare the central mystery of quantum mechanics. Our intuition fails us here. The quantum world is a place of wonder, where observation creates reality. The universe is stranger and more beautiful than we can imagine.